All right, well, today we're going to look at Chapter 7.5 Scale Drawings. Buckle in, let's take our last ride of this chapter and see how things go. Now, I'm sure many of you have already seen scale drawings, scale models at some point in your life. Just think about like maps in social studies where you've seen maps of the United States or maps of the world or whatever it may be. And so the scale drawing would be of the map of the U.S., and it represents something larger. And so it's a proportional version of a two-dimensional drawing, a two-dimensional drawing of something larger. And it could also be something that represents something smaller and it's been blown up as well. Think about like a scale model. Now, a scale model is the same idea, except for it represents a three-dimensional object, or it is a three-dimensional object. It represents something. So, for example, well, first think like model car, model train, model airplane. When you try to remember which one's the three-dimensional, think about those because those models are three-dimensional, whereas a drawing is two-dimensional. But the model, that would be like if you have like an atom that you want to study, those are microscopic, so you're going to have to blow it up to be a much bigger model. And so that would be a proportional object that's gotten larger. So it can go either way depending on what you're looking at. The scale is what determines, how much bigger or smaller the object is, because the scale gives the ratio that compares the measurements of the drawing or model to the actual requirements. So an example would be like on your map we're looking at. The distance on a map could be 1 inch, and it could represent 10 miles in real life. And that would be your scale. 1 inch for, represents 10 miles. All right? So, for example, in this map, we have a map of that state up north, and the question asks us, what is the actual distance between Cadillac and Detroit? Okay, what is the actual distance between Cadillac and Detroit? We're going to use D for distance. And some things I'm going to point out to you is that we need to have our scale to figure this out, and there's always going to be a scale somewhere. Our scale is written right over here. And our scale says it's 1 centimeter, so 1 centimeter represents 50 miles, just like so. And now we're going to write the other part of our proportion. Well, we either are going to have a centimeter measurement or a mile measurement that we can plug in. Well, I can see Cadillac on the map right here, and I can see Detroit right here. And if I was to use a straight edge ruler, I could measure the distance between the 2 points. And when doing that, I would find out that the map distance is about 3.5 centimeters. So I can go ahead and put that 3.5 centimeters up here where it's centimeters. And then the rest of this would just be D, because I'm trying to find out what the unknown measurement is in real life. All right? So then I'm going to cross multiply. 1 times D is D. And 50 times 3.5 is 175. So that's the solution on my of my proportion. And since this is a word problem, we want to write this answer in a complete sentence. So the distance between Cadillac and Detroit is about 175 miles. All right? Hopefully that made some sense to you. Let's take a moment and try this on our own. So at this time, I want you to pause your, well, in a second, you're going to pause the your iPad video to view this, see if you know how to do this on your own. I do want to point out that you would normally have to use a ruler and measure to see what the distance is, because it asks you what is the actual distance between Traverse City and Marquette, and you'd use a ruler to measure that. I've gone ahead and done that for you. So the map distance is about 3 centimeters, and let me remind you that the scale is here. So go ahead and try this problem out and see how you do. Okay? All right, let's go ahead and check this out. Again, you're going to write your scale, which is 1 centimeter, for represents 50 miles. And we, this time, are given 3 centimeters. And we need to find out the number of miles. So D times 1 is just D. 3 times 50 is 150. So the actual distance between Traverse City and Marquette is 150 miles. All right, let's go ahead and move on. You're doing great. All right, now that was an example of when we're going to use a scale drawing. Now we're going to look at a scale model. So looking at the scale model, what I've marked off here is the thickness of the liquid outer core. And the problem in here says the liquid outer core of Earth is 2,300 kilometers thick. A scale model, which is this model that you see in front of you, of the layers of the Earth has a scale of 1 inch for every 500 kilometers. And so your question is, how thick is the liquid outer core of the model? I do want to point out that we are given this information. We're given 2,300 kilometers thick is the liquid outer core, right? So we're going to go ahead and set up our proportion. And again, we start off with the scale, just like with the scale drawing. And we're going to do 1 inch, and that's going to be for every 500 kilometers. And this is going to equal, this time we're given the kilometers, we're going to put down 2,300. What we don't know is the inches, so we can just put X down, that's fine. And now we're going to have to cross multiply. So 23 times 1 is 2,300. 500 times X is 500X. We're going to divide both sides by 500 to solve this. And when we do that, we get X equals 4.6. So the liquid outer core of the model is 4.6 inches thick. All right, that's how you do a model problem. I forgot to put an example or a practice problem for number 2. I think from what I've seen in class, you guys understand how to do this. So see me if you need some more examples of this. But I'm going to go ahead and bypass practice on this one. Okay, we're going to get to our next concept to learn in this section. It's called scale factor. Now, we've talked about scale. Scale would be when we have two different units, like inches representing kilometers or miles, or centimeters representing meters, or whatever the case may be. Scale factor is if you can take the scale and it can be written with no measurements. What that means is you have to have both parts of the scale being the same type of unit, so centimeters to centimeters, inches to inches. If you can do that, you can actually write it without units. And so instead of having 1 inch for every 10 meters, you could have just something like 1 over 230. That 1 to 230 is your scale factor, and there's no units needed. I'll explain more as we go. So for number 3, the example, says the scale model of the Sergeant Floyd Monument is 10 inches tall. So this is the scale model, is 10 inches tall. The actual monument is 100 feet tall. So we have two parts we're going to solve here. The first part is A, what is the scale of the model? So we're going to start off with the information we know. We know we have 10 inches, and we know we have 100 feet. And we know that 10 inches and 100 feet refer to each other. So the model to the actual is 10 inches to 100 feet. We're going to take this information and make it into a scale. So what we want to do is we want to simplify it. So we can divide both 10 and 100 by 10, and we get 1 inch and then 10 feet. And so this becomes our scale, right? So the scale is for every inch, it represents 10 feet. Now the scale factor, what we do is we take our scale, which is 1 inch, 10 feet. And we want to write them both in the same unit. It's typically easier to write them both as a smaller unit. Because if I go the other way around, a lot of times I'd have to have a partial number, like a decimal number or a fractional number, which you don't want to do. So instead of making them feet, we're going to make them into inches. So by doing that, 1 inch represents 1 inch. And there are 12 inches in a foot. So we're going to do 10 times 12, which will end up getting us 120 inches. Now, if we could simplify now, we would, but it's already been simplified. So the answer would just be 1 over 1/20th. And so the scale factor is telling us that that model is 1/20th the size of the actual monument. That's all scale factor is telling you. All right, how about you guys give this next one a try? This one says a drawing has a scale of 1 millimeter to 20 centimeters. What is the scale factor of this drawing? So you guys give this one a try. All right, I'm going to go ahead and go through this with you. So again, what we do is we're going to start off with the actual scale, which is 1 millimeter to 20 centimeters. All right, and I want to make these both into the same measurement. So again, I'm going to go to the smaller unit. So I'm going to keep this as millimeters. And as a refresher on how to do metric system, there are 100 centimeters in a meter, because we use the meter as our base unit of measure. There are 1,000 millimeters in a meter. So if I take that down, that means that there are 10 millimeters in every centimeter. A millimeter is about the thickness of a dime. A centimeter is about the thickness of, or the width of your of your pinky nail or so. And so there are about 10 dimes that fit thickness-wise in the width of your pinky. So what I'm going to do is I'm going to take 20, I'm going to multiply it by 10, and I'm going to get 200. So it's 200 millimeters. And I can write this as 1 over 200 without any units written, because they're the same. And so it tells me that the scale drawing is 1/200th the size of the actual whatever it is you're measuring here. Okay? That is scale factor. Okay, down to the good stuff. We're now going to look at, this is a 3-part question. We're looking at a computer chip. And in this case, the computer chip drawing is a bigger version of the actual computer chip. That happens sometimes. And so what we're going to have to do here is we're going to, follow the directions, I guess. It says the scale drawing of a computer chip helps you see the individual components of the chip. Part A is asking us to find the perimeter and the area of the computer chip in the scale drawing. Okay, so we're finding the perimeter and the area of the computer chip in the scale drawing. That's the first part we're going to do. All right. So let's go ahead and take a peek at this. Information that we're given. We know that our scale is 1 centimeter in the drawing represents 2 millimeters in the actual computer chip. And I'm going to go ahead and label this as A. And this is going to be the drawing. And for the perimeter, to do perimeter, we need to know what is the length of one side of this square, because this is a square computer chip. You would normally, if I was to give you a picture, you would normally take your ruler and measure it. I'm going to go ahead and tell you what this measurement is. From here to here, one side, this is 4 centimeters. All right? And so if it's 4 centimeters, you know that this is 4 centimeters as well. Right? So to find perimeter, all we're going to do is we're going to take, perimeter is just adding up all the sides. If all the sides are equal, and there's 4 sides, we can just take 4 times 4 and get 16 centimeters. So 16 centimeters is our perimeter in the drawing. Now for the area, all I do for area is you multiply base, like base times height or length times width, or in a square, you take one side and you square it. So I could take, we have the side measure is 4, and I square it, and that gets me 16. And it's going to be 16 centimeters squared because it's area. All right, now that's part A. Part B, I'm going to do, it says for part B, find the actual perimeter of an area of the computer chip. So the first thing I need to do is I need to figure out what are the measurements of the actual computer chip. And in order to do this, I need to use the scale to find out, what is the side length of the computer chip. That's the first thing I need to figure out. So for this, I'm going to look at 1 centimeter is representing 2 millimeters. And I know that the side length of the drawing is 4 centimeters. And so I want to find out what's the side measurement for the actual computer chip. So I'm going to go ahead and multiply S times 1 is S, and 2 times 4 is 8. So 8 millimeters is the side length. Okay, so with having that information, I can find my perimeter. Because for the perimeter, if the side length is 8 and there are 4 sides, I can do 8 times 4, which gets us 32 millimeters. That's my perimeter. For the area, I know it's just, I'm going to take the side measurement and square it. So I'm going to take 8 and square it and get 64 millimeters squared. So there's part A and part B done. We found the perimeter and area of the drawing, and we found, the perimeter and area of the actual. We're going to need both of these measurements for part C. And we'll get to that here in just a moment. I want you to notice that the next page of your notes, if you're looking at this in 2018, that part can be removed or crossed out because part B is repeated. If it's post 2018, I should have gotten rid of it by now. Okay, so let's go ahead and look at part C now. Now for this section, what we're going to want to do is, let's see what it says. It says compare the ratios, drawing perimeter to actual perimeter, drawing area to actual area. You're going to compare that to the scale factor. So we have 3 different things that we are wanting to find out. I'm going to go ahead and begin with scale factor. Okay. We need to figure out what the scale factor is so we know what we're going to compare everything else to. So for the scale factor, as you remember, we need to come up with what is the scale. And remember that the scale that we had was, hold on, let me redo that. The scale that we had was 1 centimeter to 2 millimeters. Okay, so we're going to have 1 centimeter to 2 millimeters. And to make this our scale factor, we're going to have to write them as the same type of unit. So in order to do that, our smaller unit is millimeters. So let's go ahead and change these both to millimeters. So 2 millimeters remains 2 millimeters. 1 centimeter, again, there are 10 millimeters in 1 centimeter. So I'm going to change the 1 centimeter to 10 millimeters. Now, if we are able to simplify this, we're going to, which we are, we can divide both of these by 2. And so we end up having 5 millimeters over 1 millimeter. And so this ends up being 5 over 1 is our scale factor. Okay, and then our next part we need to find out is the drawing perimeter compared to the actual perimeter. All right, so let's look at perimeter next. When we're looking at perimeter, we had the drawing perimeter was 16 centimeters, and the actual perimeter ended up being 32 millimeters. So we have 16 centimeters to 32 millimeters. All right, and so at this point we're going to go ahead and make any changes we can through simplifying if possible. So 16 and 32 can divide both of them by 16, which changes this to 1 centimeter over 2 millimeters. And if you, at this point, recognize this is the exact same measurement as where we started, then you know that this would eventually lead us to 5 over 1. So if you see that and you recognize it, I'm fine with that. However, just to prove it to you, I can make this 10 millimeters over 2 millimeters. And then I could change this to 5 and this to 1. And again, it gives me 5 over 1. Okay? That is for the perimeter. Finally, for the area. Again, we're going to be doing the drawing area. The drawing area to the actual area. So the drawing area was 16 centimeters squared, and the actual area was 64 millimeters squared. So I'm going to have 16 centimeters squared over 64 millimeters squared. So the first thing we're going to do is we're going to simplify if we can. 16 goes into 64 4 times, so I have 1 centimeter squared to 4 millimeters squared. And let me see if this makes sense to you. If I do 1 cm, 1 centimeter, times 1 centimeter, I get 1 centimeter squared. And if I do 2 millimeters times 2 millimeters, I get 2 millimeters, well, I'm sorry, I get 4 millimeters squared, right? So with that being said, what I can do is I can say this is the same thing as 1 centimeter over 2 millimeters, and I'm going to square them. So that means that it's basically 1 centimeter over 2 centimeters squared times 1 centimeter times 2 millimeters squared, which would get us to where we start off with 1 centimeter squared over 4 millimeters squared. Hopefully that makes sense to you. Now this is the same thing. Again, if you notice, we have 1 centimeter over 2 millimeters, which is right over here. And so this is the same thing as, again, I'll work it out for you. It's the same thing as 10 millimeters over 2 millimeters squared. And then I can go ahead and make this into a 5 and this into a 1. So I end up getting 5 over 1 squared. And so if I read my final answer here, if I want to answer it, they're asking us to compare these three ratios: the drawing perimeter to actual perimeter, the drawing area to actual perimeter, or actual area, and the scale factor. They want us to compare all of them. So the ratio of the perimeters, which is the blue here, is equal to the scale factor, which we proved right here. And the ratio of the areas is equal to the area of the scale factor, which we proved right here. So that's how you put this into words. All right, next we're going to go through and we're going to answer, well, I'm going to have you guys try 4A, 4B, and 4C. And again, I just want to show you that for each one of these, this is 4 centimeters, 4 centimeters. Again, this, 4 centimeters, 4 centimeters. And this is 4 centimeters, 4 centimeters. I just want to make sure that you know it's the exact same computer chip we're using for this one. It's just that now the scale of the drawing of the computer chip is 1 centimeter to 3 millimeters. So the actual computer chip is a different size. So it's no longer 2, it's actually going to be 3. Okay, so I just want to make sure you guys are aware of this. So go ahead and give this a try, and we'll check in just a little bit. Okay, well, let's take a look at this. The first thing you need to do, it says to find the perimeter and the area of the computer chip in the scale drawing. So, as we, and the very first question said the scale of the drawing of the computer chip is 1 centimeter to 3 millimeters. And it then goes on to say, how do the answers in part A through C change, justify your answer? So for our first question here, the perimeter of the perimeter and the area of the computer chip in the scale drawing. Well, since they are both 4 by 4, our perimeter, actually I'll do this, our perimeter would be 4 times the 4 sides, giving us 16 centimeters. And the area this would be 4 squared, which would get us 16 centimeters squared. And I would go on to say that the answers did not change. Right, because the area and the perimeter are the exact same as from the original problem when it was 1 to 2. All right, let's go ahead and move on to part B. Find the actual perimeter and area of the computer chip. Well, this part has changed. It's no longer 1 centimeter to 2 centimeters. It's now 1 centimeter to 3 millimeters. So, the first thing we need to do, we need to find out what the measurement would be for the computer chip in, the actual computer chip, to find out what the side length is. So, we go with our scale, which is 1 centimeter to 3 millimeters. And the information we have is the model, or our drawing, is 4 centimeters, so I'm going to put 4 up here. We don't know what the actual side measurement is. So we're going to do our cross multiplying. We get S times 1 centimeter is S. Then we have 3 times 4 is 12. So 12 millimeters would represent what the side length is of the computer chip. With that being the case, then, we'll go ahead and do the perimeter. So this is the perimeter, and this is of the actual, right? So the actual. So the perimeter, we take the side length 12, we're going to multiply it by 4 sides, and we end up getting 48 millimeters. And then for the area, we take the side length, 12, we're going to square it, and we get 144. So 144 millimeters squared. So now we have the perimeter and the area, and again, I guess you could say that the perimeter and area both increased. Okay, so the final part here. Now we're looking at comparing the ratios of the drawing perimeter and the drawing area to the actual area and the scale factor. So we're going to compare those to again, the scale factor. So for our scale factor, let's begin with that. With scale factor, we begin with 1 centimeter to 3 millimeters. We always start with the scale. And that is the same thing. Well, we're going to change these both to millimeters. So that's going to be 10 millimeters to 3 millimeters. We can't simplify that anymore. And so we're going to just write this down as 10 over 3. That would be the scale factor. Then we go to the perimeter part. So if we go back to the drawing perimeter, it's 16 centimeters. The actual perimeter is 48 millimeters. So I'm going to have 16 centimeters over 48 millimeters. And then the question is, can this be simplified? And yes, it can be. 16 goes into 48 3 times, so it's going to be 1 centimeter over 3 millimeters. And now we can change these both to millimeters. So 1 centimeter is the same thing as 10 millimeters over 3 millimeters. So we end up having 10 over 3. As you can see, with the perimeters, it stays the same as far as like it's the same thing as the scale factor, right? Finally, with the area, the drawing area is 16 centimeters squared. The actual area is 144. So we have 16 centimeters squared over 144 millimeters squared. And we can divide both of these by 16. And so this will become 1 centimeter squared. And the 144 divided by 16 is 9, so 9 millimeters squared. And again, 1 times, I'm going to show you this. So if we have 1 centimeter over 3 millimeters times 1 centimeter over 3 millimeters, we would get 1 centimeter squared over 9 millimeters squared. So this can be written as 1 centimeter over 3 millimeters squared, which is the same thing as 10 millimeters over 3 millimeters squared. So this ends up being 10 10 over 3 squared. And so, for our final answer, as far as how, comparing this to the scale factor, we can say that, now I'm going to go ahead and type this out, so give me one moment. So, in conclusion, we find out that the ratios change, but the relationships of the scale factors don't. The ratio, that's probably the most important part here, the ratio of the perimeter is equal to the scale factor, and the ratio of the areas is equal to the square of the scale factor. So I hope this helps you guys. I tried to condense this down a little bit. I think I was able to cut off like 7 minutes. So best of luck with your work, and we'll talk to you soon. Bye.